Okay, in this particular problem, we're going to be talking about the combustion of a hydrocarbon. A hydrocarbon is any compound that includes carbon and hydrogen. In this particular case, we do not know the empirical formula of the hydrocarbon, thus I have put CX and HY. Now, hydrocarbons have some basic properties, such as when they combust in the presence of oxygen, they produce carbon dioxide plus water. Now, knowing that, we can we can ascertain a lot of things. For instance, because water is the only compound on the product side that has hydrogen, all of the hydrogen from here has been converted into the hydrogen in the water. So we can find the empirical form, we can find the moles of hydrogen, which will help us find the empirical formula of the hydrocarbon. So in this particular case, we have 2.2 grams of water that are produced. So if you start with the 2.2 grams of water, and then you you divide it rather by the molar mass of water. So it becomes for every 1 mole of water produced, there are 18 grams of water produced. So you can cancel here by using dimensional analysis. And what you also have to include is that for every mole of water, there are 2 moles. Every mole of water has 2 moles of hydrogen. So you have to multiply by that 2 moles here. So when you solve for that, you get 0.24 moles of hydrogen. Now, to solve for the carbon dioxide. They give you carbon dioxide in liters. So, keeping that in mind, they also tell you that the combustion occurs under standard conditions, which mean 0 atmospheres of pressure and 25 degrees Celsius. So, knowing that, you have a conversion factor, which happens to be that for every 1 liter, there are for every 1 mole, there are 22.4 liters produced. So keeping that in mind, you have 3.6 liters of carbon dioxide times 1 mole per every 22.4 liters. So when you solve for that, you get 0.16 moles of carbon dioxide. Now, keeping that in mind, now you have the moles. The empirical formula is expressed in a mole ratio, but obviously the subscripts have to be whole numbers. So you have to take that 0.24 and divide it. You take the 0.24, which is the larger number, which we had calculated the moles of hydrogen, and divide it, not moles of CO2, moles of carbon, and divide it by the 0.16 moles of carbon, which gives you about a 3:2 ratio, which tells you that in order to have a balanced hydrocarbon, in order to find the correct empirical formula of the hydrocarbon, you have to have 2 carbons to every 3 hydrogens.